Good morning, everyone. Welcome to Miss Adamo's fifth grade class from Gilbert Lincoln Elementary School in Blacksburg. We're so glad to have everybody here this morning with Paul and Lauren from Virginia Tech, who are going to talk to us about building an underwater bicycle in just a minute. My name is Phyllis Newbill, and I'm the Outreach and Engagement Coordinator for the Virginia Tech Science Festival. I want to also introduce Hasib Aleem, who is the assistant to the Outreach and Engagement Coordinator. And we just appreciate everyone being here today, and we're going to learn some science and see what cool things are happening at Virginia Tech.
So yeah, I'm Paul.
I'm Lauren.
So I'm Paul. I'm the controls lead engineer on the human-powered submarine team at Virginia Tech. I'm a mechanical engineer. I'm a senior.
So I'm Lauren. I'm our safety lead engineer. I'm also a senior, but I'm studying ocean engineering.
Awesome. So just a little bit about our competition. Basically, we have those submarines, as you see kind of on Lauren's left and right in her picture. And what we do is we race those submarines. So it's kind of like a drag race style. So it's whoever has the fastest speed is, the winner. And you get ranked, of course. So that's kind of what we do, what our competition is, what our goal is to just be the fastest. However,
so in summer 2017, our competition is every other year, and it's the international submarine races. So it's a really great opportunity for us to meet engineering students from other schools. But when we went in 2017, we ended up having a lot of issues with our submarine.
For example, one of our main systems in the submarine is what makes it go forward. So the kind of basically the thing that you pedal, and that broke right away. Actually, we didn't even cross the start line. The past 2 years since 2017, we worked on that, and you got to make mistakes, of course, to find better solutions. But we needed to start to make a new submarine, basically, because that submarine broke. So this is us basically making the shell of the submarine,
which is called the hull.
Which is called the hull, Hull. So basically how you make it, or how we make it, is you basically put fabric, or a very strong fabric, so like your shirt material, onto the mold, and then you basically put a glue on it, and then it solidifies it together because of the glue, and then that holds the whole shape of the submarine.
Because we compete underwater, obviously we can't breathe, and unlike sort of a regular Navy submarine that you might be thinking of, our submarine has no air on the inside. It's fully flooded, which means that our pilot has to be in complete scuba gear in order to compete. The pilot, actually, we call it a dead man switch, so they're always holding on to this switch, and if they were to ever let go of this switch for any reason, it would release that safety buoy, which communicates with the Navy divers who work at our competition that our pilot needs some sort of help. So in addition to our pilot, we also just need divers to help out at competition support, bring the submarine down. Also, when we do different testings, we need people to be able to go down.
So then for our submarine, we also need the propeller. We made it out of aluminum.
So then we also need to be able to steer our submarine. So we do that through what we call control surface. So a control surface works just like fins on a fish. So depending how you move the fins, it causes our submarine or a fish or whatever to move in a certain direction. So how the pilot pilots the submarine is they actually are laying on their stomach, sort of almost in a Superman position on their stomach, and they have two joysticks right at their hands. One is going to move the submarine left to right, and one moves it up and down.
So then we need a new gearbox. So the gearbox is basically what turns the propeller to drive the sub forward. So it's very important.
Like when you ride your bike, it causes your wheels to move. It's the same concept. You pedal, but it just causes the propeller to move instead of a tire.
And then, so before the race, of course, practice makes perfect. So the picture on the right is us in a quarry. And a quarry is basically like a hole dug into the earth with water in it. So it's a lot bigger than the pool we have on campus.
So finally then, once we got all our components together and our hull made and attached our control surfaces and put the gearbox inside, we were finally ready to compete at the 15th International Submarine Races. That long strip of lights on the bottom. So that's how the pilot knows where they're going. One of the most important things about engineering is learning from your mistakes. You're going to make a lot of mistakes. Things are going to happen, but sometimes mistakes can be really valuable. If you know what went wrong, you know how to fix it in the future to make an even better design moving forward. So our fastest submarine was Trident, which came in at 3.29 knots. So a knot is a nautical mile, which is how we measure speed of marine craft. So a knot is actually about 1.15 regular miles.
How heavy is the submarine?
So I think it's less than 100 pounds, but it's probably around 100 pounds.
The water weight actually inside the submarine definitely weighs.
Oh yeah, totally. We have to basically weight it down or float it up so it kind of sits neutrally in the middle of the water.
We call that neutrally buoyant, when you're perfectly centered in the water column.
Because it like neutrally floats, I guess.
So we have some weights and foam that we can put in the submarine to adjust its buoyancy. So every time it's a little different depending on the weight of the pilot and their gear and everything else you put in the submarine.
It doesn't really look like someone would fit inside. How does someone fit inside?
It does look pretty small. Our submarine's only about 8 or 9 feet long, but that's still enough for a pilot to fit inside. Our pilot pretty much perfectly fits inside, so they actually sort of have to climb down through it and put their feet in the back of the submarine, and then they're laying on top of it, and then we put that hatch over their head. So it's a sort of at least a 2-person job to get somebody inside the submarine. You can't do it all by yourself, but there is enough room for a pilot, though there are some height requirements. Like I'm actually too short to pilot the submarine.
Where do you race?
So we race international submarine races, and it happens at a Carteret Naval Base, which is in Bethesda, Maryland.
Why did you decide to build this submarine?
It's a really good way for all of us to get hands-on engineering experience, because a lot of the time in class you just learn about things, but you don't actually get to do anything or build anything. So joining any kind of engineering design team is a really good way for us to actually get real hands-on experience. And the cool thing about our team is it's completely student-run. So we have a professor who's a sort of our advisor, but she doesn't actually really work on the submarine. So we get to do everything by ourselves and run it almost like, we were running our own engineering company, which is pretty cool.
How many people did it take to build the submarine?
How many people or how long?
How many people?
How many people?
The past submarine, there's probably about 30 to 40
Yeah.
people on the team. However, people do a lot of different things, and of course we're students, so some people put in more time on the submarine than others. But about 30 people, I would say, had a hand in helping the submarine race. So why we decided to name our sub Trident is because, well, we basically just had a bunch of name ideas, and then we voted on them, and Trident won, because Trident, of course, is like what Zeus has.
Poseidon.
Poseidon, the Greek god of, I guess, the ocean.
The seas.
She'd know better than me. So, we're a submarine, we're in the seas, so.
It was more just a lot of people came up with sort of nautical words, and we all voted on them, and that's the one that won.
All right, well, I thank you all so much again, and this has just been a great meetup, and so we're going to make this video into a 10-minute video and share it on the Science Festival Day. That will be available on November 7th. So I hope that you all will come and see your video, as well as videos from lots of other classrooms and learner groups around the area on that day. So look at the Virginia Tech Science Festival. All right, thanks y'all so much. Have a great afternoon.
Thank you.
Thank you, guys.
Bye.